Hi, my name is NABIL AZLAN. My matric number is 211090950. The title of my final year project is Design and Development of MPPT Rooftop System Comparison between Hill Climbing and Particle Swarm Optimization. The objective of my project is to analyze and compare the performance of two MPPT, which is HC and PSO, in extracting maximum power from the PV systems under constant irradiance and partial shading conditions. This project was conducted using PSIM software through simulation-based modeling. PSIM was selected due to its specialized library for power converters, its fast simulation speed, and its custom control block programming. Additionally, PSIM integrates well with user-defined C code, making it ideal for MPPT algorithm development and testing compared to tools like MATLAB and Simulink. So, which I would get the result like this, which has the better performance in graph and looks better. Now I have three objectives in my project, but the one I want to discuss here is how to implement the partial shading conditions using the PSIM software. So as you can see, this is the circuit that I designed, which is a MIC converter, module integrated converter, which I use the VLOOKUP and then integrate the code, the VLOOKUP table, and then extract from the Excel file to mimic the irradiance profile. So as you can see here, I've implemented it in the VLOOKUP table, and then I've run it go through the solar module, and which I set it like this, and then we've run the simulation of the converter and wait for the result. So here, this is the irradiance patterns that we use to mimic the partial shading condition, which is from 1000 irradiance, and we go through it one by one, which is going from 1000 to 900, and then until the 600 irradiance, and then we do the sudden from 700 to 1000 irradiance to mimic the partial shading condition of like sudden weather changes. Now the second objective is to implement the algorithm, which is hill climbing and then particle swarm optimization algorithm into the converter by using the C block here. So why I use the PSIM is because it has the C block that we can implement the algorithm and the coding into the converter to make the maximum power point tracking. Here are the coding, and then after we implement it using the C block, then we run it to get the graph of the duty cycle. Here, this is the graph of the duty cycle for the hill climbing algorithm that implement integrated into the MIC converter. So this is the power output of the MIC for hill climbing under partial shading conditions. This is the comparison with the result of comparison for MIC under 1000 irradiance, which is constant irradiance. So we can see this is the result for the output of the hill climbing algorithm in module integrated converter. By using the hill climbing algorithm, we see that it is playing at the P max of the solar module. Now we see here, this is the particle swarm optimization output, which is not good. Despite its advantage, PSIM has some limitation. First, it doesn't support high resolution graphical plotting or advanced numerical analysis like MATLAB. In conclusion, this project enhanced my understanding in renewable energy.